record here. Welcome everyone. Thanks for coming to the seminar today. We're really fortunate to have someone outside of KU today. So Dr. Lisa Hamrick is a postdoctoral fellow at the University of South Carolina under Jane Roberts in the Neurodevelopmental Disorders Lab. But she got her PhD in clinical psychology at Purdue under Dr. Bridget Kelleher, where she was awarded an F31 from NIH for her project, Analysis of Early Vocalization Features in Children with High Genetic Risk for Autism. Her work focuses on early social communication and language development of children who are at increased likelihood for autism and other neurodevelopmental conditions, including children with neurogenetic syndromes like Fragile X syndrome, Down syndrome, and Angelman syndrome. Lisa is passionate about developing and utilizing assessment methods that are strengths-based and which capture the full range of abilities of children with neurodevelopmental conditions. So Dr. Hamrick, we're really excited to have you, and take it away.
Yes, I'm very excited to be here and be talking about this. This is a kind of nice, comprehensive show of the work that I've done over the past couple of years. I am a fresh postdoc, so I just graduated with my degree in clinical psychology in August. So a lot of the work that I'll be talking about will be from my work at Purdue with Dr. Kelleher, and kind of integrating all of the different pieces of that work to look at how we can optimize assessment for these populations. So just to kind of give some context to how I ended up in this area. So while my interest is primarily in how kind of social communication develops in autism, most of my work is in social communication in kiddos that have neurogenetic syndromes. And this is kind of based in this model, in this kind of prospective development model, where we know that children that have neurogenetic syndromes, like Down syndrome, Fragile X syndrome, tend to have higher rates of autism diagnoses than we see in the general population. And so by kind of looking at early development in these syndrome groups, that most of which can be identified from birth, we have this really nice kind of prospective look at how development and how these, autism features might emerge in these groups that we know the supposed genetic underlying reason for why we see these differences, and are able to look at how these map onto later autism outcomes, but really broad developmental outcomes as well. And so I'm particularly interested in social communication, I think, because my initial exposure into, or kind of jump into the neurogenetic syndrome world, was with children with Fragile X syndrome. And I did a lot of kind of like hands-on work with those families, and it was just kind of very clear that this domain of social communication was one that was like at the top of their minds. It was like always a question of like, that was where they wanted to see their child gain skills. A big concern was always whether their child could communicate what they needed and kind of express themselves effectively. And then we also tend to see that within neurogenetic syndromes, this, if you think about the two domains of autism features with social communication and the repetitive behaviors, the repetitive behaviors piece can sometimes be seen more broadly in neurogenetic syndromes, or in populations that are associated with like intellectual disability or developmental delay. And the social communication piece is maybe sometimes a little more specific to like autism outcomes in these populations. So this has been a really interesting area of development. So my thought was, I'll just go in and I'll study social communication and genetic syndromes, and then I'll just map that right onto autism. But quickly learned that there's this kind of like other mechanism happening where it's really not that easy to assess social communication in neurogenetic syndromes in a reliable and accurate way. Like, we just don't have a lot of good measures that are measures that do like a good job in these populations. And I'll talk about what some of those barriers, but my initial plan kind of took this little detour into almost more of like a methodology and assessment focus. really try and figure out how do we get good information about these like early skills in these populations that we can then take back to like inform when we understand about autism, and now what we even understand about, you know, kids with these genetic syndromes, because with limited use of or limited access to assessment tools, we really don't have great information about early development for a lot of these syndromes as well. So as far as some of the challenges that we face when we're trying to characterize early development in kids with neurogenetic syndromes, the main one is that most of our kind of like common standardized assessments tend to bring about some pretty significant floor effects when we use them for kids that have neurogenetic syndromes, just by nature of the phenotype of the different syndromes. Often, especially if we're looking at standardized scores, kids are scoring kind of at the lower end of the scales that we're looking at, and that is often reflecting reality, right? Like if we look at our bell curve, like a lot of the kids with neurogenetic syndromes, their skills do fall on that kind of like the tail end of the normal distribution of these skills. So that's useful to know for things like getting access to services or being able to kind of contextualize a child's skills within their broader development. But it's less useful when you have a group of kids who who have a genetic syndrome and who we know have very, unique strengths and challenges in terms of their communication skills, but we're really not able to capture variability there. So when you have every kid with Fragile X syndrome kind of getting the same score on a measure, that probably means we're missing something in terms of some individual differences. And it also makes things difficult to kind of measure skills over time too, because if you, if you're scoring at the measure floor across age, especially when we're, again, looking at standard scores, it could be that kids are gaining skills. They're just kind of gaining them at a slower rate than you would see in a neurotypical population. And so, but that, those increases or those gains are not really being reflected in like the outcomes of the measures that we're using. And that kind of feeds into this next point, which is that a lot of times the measures that we use are kind of focused on like, okay, what skills has the child acquired? And for kids with neurogenetic syndromes or just delays more broadly, a lot of times that can feel like, well, they're not doing this and they're not doing this and they're not doing this. And so just from like a rapport and like a morale standpoint, this can be really frustrating for families who, they're seeing their child gain skills, but it's, they're not seeing like the people that they're working with, like, acknowledge that. It can be frustrating for kids because we're, asking them to do lots of things that we maybe don't even really expect them to be doing. It's, that's just the assessment, that's how the assessment works. And so that's how we kind of administer it. And then it, can become frustrating and discouraging for the child themselves. And then there's also this piece of a lot of assessment measures that are kind of more commonly used or more popular, have these pretty strict standardization protocols, for good reason, right? So we can get valid scores and reliable scores. But a lot of times kids with neurogenetic syndromes have, they're more likely to have like anxiety or attention problems that are going to affect how they perform on these measures that might not necessarily reflect like their actual abilities in these domains. And those just aren't going to, then the score on this measure is not going to really capture what they can actually do. So in one of the very first studies that I did at Purdue, we had just kind of like a longitudinal study of early development for kids with various neurogenetic syndromes. So in this study, we had kids with Angelman syndrome, Prader-Willi syndrome, Williams syndrome, and then we had a typically developing control group. And we looked at, one of the measures we collected was the communication and symbolic behavior skills, the infant toddler checklist. So this is just a very coarse screening measure of social communication, a fairly popular one in the field. And we looked at just kind of overall scores on this measure and how much variability we're capturing for kids with genetic syndromes on this, again, very coarse measure of social communication. And so what we found was not groundbreaking, but it was nice to have some data to back it up, was that kids with the neurogenetic syndromes had higher rates of floor effects in terms of their standard scores on this measure. And we saw this especially in the children with Angelman syndrome, that's a genetic syndrome that's associated with pretty kind of significant communication impairments. And so this kind of mapped on phenotypically what we would expect. But practically what this means is that if you have 10 kids with Angelman syndrome and give them this measure, 9 out of 10 of them are going to get the same standard score on this measure. Whereas again, if we were to see each of those kids individually, they probably do have some differences in terms of what kind of communication skills they have mastered, or nuanced ways that they use communication to have their needs met. Like, I just remember talking with caregivers of kids with Angelman syndrome, and they're like, I know that they're asking for this, or like, this is what they want. And so something that child is doing is communicating that. It's just not being captured in this measure. So most of my work from that point kind of focused on how do we address these limitations. And so I'm going to talk about pretty briefly about a statistical approach that I've used to look at kind of contextualizing some of the measures that we have, and then a lot about different kind of methodological approaches, and then focus on different constructs that theoretically capture more variability and are a little bit more meaningful to these populations in terms of their social communication skills. So as far as kind of my first pass of addressing these issues statistically, I use this same measure, the CSBS infant toddler checklist, and applied a statistical approach called generalizability theory, which is like a multi-level model-based statistical approach that very coarsely, the goals are to look at the different sources of like systematic variation in item level scores, and then to calculate some more kind of nuanced metrics of reliability. So kind of going beyond just like test retest reliability or like internal consistency. We're looking at different, almost like different applications of how you could, how many times you collect the measure, how many observations you're looking at, and how reliable those scores are. So I'm going to focus on the different systematic variation, because I think this is a really good example of, or kind of visualization of how, if we maybe know a little bit more about how the measure is working, it can kind of guide how we might apply it in the field. So with generalizability theory, you essentially can break down item level scores and look at the variance that's accounted for by different factors or different variables. So we in this study looked at variance accounted for by child level factors, so like individual differences in the green here, and then variance accounted for by age in the yellow, and then variance accounted for by like item content, so like what skill the item was measuring, and then also interactions of those different variables. So the most striking difference was definitely looking at, the difference between how the variance decomposition broke down for the children, the low risk control group compared to the Angelman syndrome group. So for kids with, in the low risk control group, the most variance, so like the factor that was, best at predicting what any given item's score was going to be, was the child's age. So if you knew how old the child was, you could pretty reliably predict what their score on an item was going to be. And that makes sense, right? Like most 24-month-olds, kind of like the upper range of where this measure is meant to be used. Most 24-month-olds are going to get 2s across the board, right? Most 6-month-olds are going to get 0s, maybe 1s across the board. And so in the, a neurotypical sample, that is what you would expect. When we look at kids with Angelman syndrome, there's actually very little variance accounted for by age. So really, if you have a child with Angelman syndrome, the most kind of relevant factor at predicting what their score was going to be on any given item was what was that item measuring. So what this says is that I forget what the items were that like we got more variability or more endorsement of for kids with Angelman syndrome, but you can, if there's items about how many words the child uses, like individuals with Angelman syndrome really maybe master one or two, a handful of words like across their lifespan. So most likely every child in our study had a 0 on, how many words do they use. So if that's what the item's asking about, you're pretty, you can be pretty confident in what the score is going to be. And a little bit more child level factors too across all of our syndrome groups. There was a little more variability just based on like individual differences than there was for kids in the low risk control group. So this was a really interesting way to, again, kind of guide how we might use this measure. So it definitely helps to kind of understand how you might interpret scores on this measure, where you kind of know that if you're giving it to a kid with Angelman syndrome, scores, we don't expect too much variability among the different children. This was also a longitudinal study, which was how we got the variance accounted for by age. So for kids with Angelman syndrome, age is accounting for very little variation. So it's almost, we had these families fill this out 5 times across early development, and really we just needed one. We needed one observation, and this gave us a good picture of how that child was going to perform on this particular measure. And then we were able to kind of we did this kind of decomposition within each of the subscales of the CSBS too. So it was, and we saw some differences in terms of like the social scale was like more reliable for Williams syndrome than Prader-Willi syndrome, or kind of different, more nuanced differences like that, that can help guide, how much stock we put in a score that we get from these different measures. So that was kind of my first pass at looking at this, like statistically, kind of just giving more context to like the measures that we're using, and informing maybe some, how do we kind of capitalize on what they do well, and use that to kind of optimize how we're assessing social communication for these measures that already exist, right? That's the nice part, is you don't have to develop anything new. You can really see how the measures we have, how they're doing. However, I wanted to look at some new things. I wanted to look at some new constructs, because it really seemed clear, especially from this measure, that this was just not getting at skills that we were seeing a lot of variability with. So I was really interested in looking at trying to find some variables or some features that we were going to see more variability, that we were going to be able to see some differences across development, and that we felt like might be related to outcomes, in particularly like autism outcomes. So my interest in kind of this like early language development really took the lead here, where I was interested in looking at a couple different features of early vocalization. So the first feature that I looked at was volubility, which is just the amount of vocalizing that a child does. And I guess with each of these features that I'll talk about, they are kind of based in the fact that we know that we see differences in these features in autism too. So in autism, we see lower volubility in early development than we'd expect from like a neurotypical population. I was also interested in looking at canonical babbling. So these are vocalizations that have consonant sounds in them. They sound a little bit more like kind of that classic baby babbling. I think if my sound works, I have some examples. So all of those have kind of that like consonant vowel, quick transition, babbling sound to them. And we know that in autism, canonical babbling tends to be reduced, like the amount of, or the proportion of canonical vocalizations to, earlier kind of like more vowel sound vocalizations, it tends to be lower, and then canonical babbling itself emerges a little bit later in autism. And then the final feature that I was interested in, or am interested in, is vocalization pitch. So this is exactly what it sounds like. It's the pitch of the sound of your voice. And so there's some emerging literature showing that vocalization pitch tends to be higher in younger kids with autism. And I was really interested in this because just thinking about, like, you know, in older individuals with autism, or for, you know, we think about prosody, or like the sound of the tone of voice. And this seemed like an interesting way to look at maybe like a baby precursor of that almost, like how are kids modulating or varying the pitch of their vocalizations. And really that's the case with all of these features, is that they can be assessed really early in development. You don't need to have language to be able to get a measure of these different features. And we think that they're going to be related to some meaningful outcomes too. So my first look at this was in a sample of kids with Fragile X syndrome. We analyzed their vocalizations from like a short 10-minute examiner-child interaction at 9 months, and then looked at how those vocalization features at 9 months were related to autism features at 24 months. In Fragile X, compared to a sample of kids that were at low risk for developmental delays. And so in the Fragile X group, we saw that so volubility and then complexity ratio is another measure of that canonical babble. Those tended to be associated more with like language outcomes, but average pitch, or like mean pitch of vocalizations, showed this pattern that we might expect, where at 9 months, kids that had lower average pitch or who had higher average pitch tended to also have higher levels of autism features at 24 months. So we saw this interesting kind of like association over time of these early vocal features with later autism features. So then going through that process and kind of like, to get at these features, we like hand coded, hand tagged, and like annotated all of the utterances that the child used during these interactions. And they were, 10 minutes is not a long sample, and it still took a really long time. So I was kind of motivated to see, okay, how can we know that there's some evidence that these features are meaningful. So now how can we be a little more strategic about getting to these features in a efficient way and kind of optimize our resources? So this started with integrating the language and environment analysis system into our work, so the LENA device. So for those who are not familiar, which I feel like this group is probably pretty familiar, but the LENA system is this little child-friendly recorder. The child wears it in this vest in a pocket, so it can capture all of the sounds that the child makes, but then also the sounds that they hear kind of in their immediate environment too. And it does this over a full day in the child's kind of natural setting. So we're getting a really rich language sample that can be collected in a pretty family-friendly way. And then the really nice aspect of LENA is that it also has some like automated algorithms built in that can automatically kind of identify, like it doesn't necessarily segment it, but it's identifying, classifying which sounds are happening during the recording. So what we were interested in is the, LENA tagged child utterances that happen during the day-long recording. And so whereas like we took hours and hours to hand code this from our 10-minute samples, now we have like 16 hours that we can process using where these algorithms process in like the matter of, an hour or two. So this is definitely a more efficient way to get at some really rich data. The question that we weren't, entirely sure about was whether this, how well LENA's algorithms would work in our kids with neurogenetic syndromes, just because that, that's not who the Lena was created for. So there's, with kids with neurogenetic syndromes, you're going to have like a 3-year-old whose vocalizations sound more like a 6-month-old. So how is Lena going to handle that? And then with some neurogenetic syndromes, there are physical differences, like maybe in terms of like their vocal tract length, that just might impact the quality of their voice, that we just didn't know how that was going to interact with Lena's algorithms. So we developed kind of a post-processing pipeline, which we called the utterance level processing pipeline, that kind of strategically took a subset of utterances from Lena, and we had some trained undergraduate coders kind of go through and code, first to verify, is Lena picking up the actual the target child, and then to also have them add another layer of information about the utterances that Lena doesn't capture, which is whether or not each utterance contains canonical syllables and how many canonical syllables. And so what this looks like is we take the full 16-hour recording, we pull out 10 5-minute segments of the highest volubility according to Lena, so where the child is speaking most. And so this makes sure that we have like a good, like a lot of vocalizations, a good sample of vocalizations to code. And then we also pull out 20 randomly selected 5-minute segments from the rest of the recording to add in this layer of more kind of like hopefully representative or kind of generalizable vocalization behavior from the rest of the day. So then for each of those 5-minute segments, Lena is kind of automatically identifying, okay, here's a child utterance, here's an adult female utterance. So we pull out just the child utterances and have our coders tag each of those utterances. Like I said, it's initially just or kind of the first decision is this a target child or is it not? And then they say kind of what the highest level of vocal maturity they hear in the utterances. So with words being kind of the highest level, and then canonical syllables, and then non-canonical syllables. And then they also indicate how many of each type of syllable are happening too. And then, so from that, we maybe get like a little bit more refined data. So we're kind of, knocking out some of the, non-child vocalizations, vocalizations that are maybe sound more like laughs or cries, so that we can just get to like the canonical and the non-canonical utterances. And then from those, for each child, we kind of calculate a summary across all of their vocalizations from the day. So we take all of their canonical utterances and calculate the rate of those canonical utterances, and then the interquartile range of their pitch, so kind of pitch variability. We do the same thing for non-canonical utterances and syllables. And then we also calculate the canonical babbling ratio, which is just the proportion of canonical syllables to all speech syllables. And so we finally got this paper published. It's been under review for a long time, but we did a first pass of coding Lena recordings and using this utterance level processing in children that had Angelman syndrome, and then a comparison group of children at low risk for developmental delays. And we focused just on the volubility, the vocalization rate, and then the canonical babbling ratio. And so we kind of saw this really interesting pattern where for kids with Angelman syndrome, when we look at like the canonical syllable usage, they are definitely showing this very kind of different pattern than what we see in the low risk control group, which is what we would expect. And even our low risk control group was kind of younger, meant to more map onto like developmental matching. But even in these younger low risk control group or low risk control participants, we see pretty different, pretty significant increase in canonical syllable rate in the canonical babbling ratio. At the same time, we're still seeing variability within the Angelman syndrome group. So that was exciting to see that even though, this kind of clinically valid pattern is emerging where we see canonical syllable usage kind of decreasing over age or across age in Angelman syndrome, we're still not, we're seeing some variation within this group. And then when we looked at non-canonical vocalization rate, we actually saw that the rate of vocalization or of those types of syllables was increasing in Angelman syndrome. So it was interesting once we kind of broke it down into not just overall volubility, but looking specifically at their use of non-canonical syllables. We saw that this was something that like kids with Angelman syndrome were almost like they were doing well. They were increasing and using more of these vocalizations. And so the next step will be to see, okay, is this more kind of like specific measure of volubility? How does that map onto like clinical, outcome, like language outcomes or other types of outcomes in Angelman syndrome? Like, do we see different associations there too, where like maybe this measure is more meaningful in Angelman syndrome than it might be in like a low risk control group? And then this is kind of, we did a brief foray into looking at yet another way to kind of optimize how we're coding these data. So with our utterance level processing, we coded those. Again, we had trained undergrads in psychology and speech language hearing science labs who kind of got a background in early vocal development. They had, weekly reliability meetings. And then for our kind of next step into this, we collaborated with a team in Paris who was using citizen science coding to code early vocalizations. So citizen science is this, it was new to me. I hadn't heard of this approach before, but essentially it's like we use like a web-based platform where non-trained civilians and people interested in just contributing to science could log on and just code a couple vocalizations. So we used a platform called Zooniverse. And if you go on Zooniverse, there's a full range of different kind of research projects. Like there's like reading ancient scripts and like coding whale vocal or whale sounds. So there's really some interesting, felt like ours was maybe one of the more boring projects on Zooniverse. But we essentially kind of segmented our clips down so that they were de-identified. So they were really short clips. And then had just regular people code them and code the level of vocal maturity that they heard. So basically they were deciding, did they hear a canonical syllable or not? And could they even distinguish like if it was a child or not in the clip? And so this was a really kind of cost-effective way because these were not people, we didn't have any kind of formal training for these people. There's like thousands of citizen science coders just like looking for projects to do. And so this was a nice way to get a really high volume of data without necessarily having to devote too much like manpower from our labs. There was definitely kind of like a coding and processing burden added in. So that was where our collaboration really came in handy because they knew how to process this data and kind of link it all back up and get to these measures or these constructs that we were interested in, which are these early vocal features. So in our kind of looking at how citizen science coders compare to like our gold standard trained laboratory coders, we focus primarily on the like canonical babbling vocalization feature, which is this canonical proportion. And we found that the measures that we got from citizen science coders were pretty similar to what our lab annotators. There was a pretty high correlation between those measures for each child. And this held true for our low risk control sample and for our kids with Angelman syndrome. So there wasn't really, there wasn't this, confounding factor. It wasn't harder for people to code vocalizations from kids with Angelman syndrome than it was to code vocalizations from neurotypical kiddos. And so this was really exciting as like another, just another option for how we can get to these meaningful features in a, you know, a cost-effective, somewhat time-effective strategy. So this kind of reflects a little bit of how, you know, starting with some of these early vocal features that were meaningful and that we wanted to study, we kind of looked into then, okay, how do we optimize the methods? So then in the next kind of area of my work, I feel like I went back the other way where I was really interested in, especially I think coming from, you know, collecting Lenas, where we were like, I think the idea of collecting, you know, behavior samples from kids just in their natural environment was very compelling, especially for kids with neurogenetic syndromes, where like that's where they're most comfortable and who are maybe going to be affected more by being in an unnatural setting or around people that they're not familiar with. And so I was interested in kind of using this more naturalistic assessment method to look at some other aspects of early social communication. And so the kind of next step was to start integrating this remote naturalistic assessment, which we collected remotely. So this is a paradigm that my advisor, Dr. Keller at Purdue, developed. And it is a remotely administered assessment battery for neurodevelopmental assessment. So it's called PandaBox. The whole kit is right here. Basically what we do is we pack everything up into this box, we mail it to families, and then we have a trained examiner remotely connect to this tablet, and then they're able to kind of coach families through administering different types of assessment. So the goal of this type of assessment was to be able to collect behavioral data, but then also we were collecting things like heart rate, and we had them wear the Lena during the assessment. So we were really trying to kind of like synchronize almost as like research lab grade data and see if we could collect it from families' homes. And so in a sample of kids with Down syndrome, we saw that there was pretty high in terms of like having parents administer these tasks with someone coaching them through a computer. There was pretty high fidelity across the different tasks that we asked them to administer. Kids generally stayed engaged with the tasks. And then we also kind of just demonstrated like we can get things like heart rate and vocalization behavior during each task, just the same way that we would do if the family came to us in the lab. So for looking at early social communication features, I kind of focused on one task from the PandaBox, which was the parent-child interaction, which is a pretty standard assessment context, I think. So we basically we gave families a standardized set of toys. We instructed parents to just play with their child as they normally would for 10 minutes. And then on the back end, coded some different social communication or pre-linguistic features. So the measure that I used to assess pre-linguistic features during the parent-child interaction was the communication complexity scale, which was actually developed by Nancy Brady, who is at Kansas. So you also may be familiar with this as well. But this is a measure. It's a 12-point scale. It's used to assess the level of complexity of individual communication behavior. So it's really based on the child's use of, or their use and their integration of things like eye gaze and vocalizations and gestures. And so from this scale, I was interested in kind of two aspects of it. The first was the complexity of the child's behavior. So how much are they kind of integrating these different communicative features to kind of get their point across? So each behavior kind of gets a rating in terms of how complex it is. So I have an example here of how those might be scored. So here she was looking and made a vocalization. So she would get a score of 7 there. And here she didn't shift her gaze, so that was only a 1 orientation, but with the vocalization, so that got a 3.
Oh, my turn. Is it mommy's turn? Mommy's turn?
And then here she shifted her gaze 3 times. She used a vocalization and a gesture, so she got a score of 10. That's kind of a higher complex, more highly complex communicative behavior. And so we coded the complexity of behaviors throughout the parent-child interaction, and then we also coded the communicative function. So the functions that I focused on for the questions that I had were the functions of joint attention, which is kind of that sharing enjoyment, and engagement and interaction, and then behavior regulation, which is looking at how children like express, make requests or protest or kind of express their needs. And so these constructs all kind of came into play in the grant that I was awarded during grad school. So I completed an F31 that was looking at how our analyses of early vocal features and these pre-linguistic features kind of come together to help us understand early social communication profiles and how they're related to autism features. So the grant kind of had these 2 samples where I was looking at this in a preschool cohort and then an infant cohort. For my dissertation, which is what I'm going to talk about here, I focused primarily on the infant cohort using this, using a sample of kids that had neurogenetic syndromes. So there were 39 children, 8 had Angelman syndrome, 22 had Down syndrome, and then 9 had Fragile X. And then a comparison group of children at low risk for developmental delays who were matched on age to the children with neurogenetic syndromes. And so the kind of main questions that I had were, do we see differences in the groups in these 2 types of, or in these various, early social communication features? So in early vocal features and in the pre-linguistic features of complexity and communicative function. And then kind of looking at everything together and if we kind of put the vocal features and the pre-linguistic features together, does that give us, some additional information about early social communication? And does, do we see profiles emerge that are then related to either, later autism features or developmental outcomes? And so for this study, I collected information about vocal features using the LINA and the utterance level processing system, and then also information about the pre-linguistic features using the communication complexity scale during the parent-child interaction. And so for this first research question, this is where a little bit I went back to my trying to use stats to get at some of these questions in a little bit of a better way. And I used some Bayesian analysis for these. Just to do some group comparisons. So what we saw here are that the children with neurogenetic syndromes tended to use lower proportions of lower overall rates of canonical syllables. The complexity of their communication behaviors tended to be lower, and they also used fewer or kind of less complex behaviors for the purposes of joint attention. But we saw no difference in the groups in terms of how they use non-canonical syllables, and then no differences in their vocalization pitch or the kind of complexity or their use of behavior regulation behaviors. So we saw some differences. It was interesting to see that kind of the functions panned out a little bit differently. And then that kind of fed into this next question of, okay, how do we put all of this together to help understand some of these early profiles of social communication? So to do this, I conducted a model-based cluster analysis and then kind of characterized each of the clusters that emerged there based on the different vocal and pre-linguistic features, and then looked at how those different clusters differed in terms of some relevant concurrent variables. So looking at how they related to age, how they related to genetic status, and then how they related to adaptive skills. And so cluster analysis. Ultimately, the best fitting model was like a 6-cluster analysis across all of the prelinguistic or the vocal and prelinguistic features. We saw this general pattern of this cluster A and cluster B tended to have kind of higher levels of these features, and then kind of as we went, across clusters, we started to see like decreases in terms of how their use of these features. So when trying to characterize the different clusters, it really seems like we had these two, cluster A and cluster B tended to have just kind of higher overall social communication skills, but they were differentiated in terms of whether or not they used behaviors for the purposes of behavior regulation. And then we had these kind of two middle clusters that were differentiated in terms of the complexity of their social communication behaviors. So whether they were integrating more of those communication behaviors together versus using, just gaze or just vocalizations and no gaze shifts. And then these final two clusters where they tended to be kind of on the lower end of the different features that we measured, but distinguished in terms of whether or not they used behaviors for the purposes of joint attention. And so when we looked at how these different clusters kind of mapped onto our relevant other variables, we saw, so just to kind of orient here, so we have the low risk control group on the left, and then all of the syndrome groups kind of collapsed on the right. And then the different colors are the different clusters that they were mapped onto. So the first two clusters, unsurprisingly, were entirely composed of the kids from the low risk control group. But then for the, C through E, F, C through F, we had kids from both groups kind of getting distributed pretty evenly across those different profiles. So that was exciting to see, because especially if we look at, so this figure is showing the different scores in terms of adaptive age. And so kids with, similar levels of adaptive age, or kind of, it was our proxy for developmental level, with genetic syndromes, they're showing these different profiles of social communication. So where, this is potentially one way where we can get at a little more nuance and some variability among kids that otherwise you might have just kind of would have gotten the same score across the board. And ultimately, kind of breaking things down in terms of looking at these different profiles, the ultimate goal is to have these be, clinically useful in some way. So the way that might work for these kinds of profiles might be that, looking across the different clusters, we've got, there's a kiddo here who's, their adaptive age is more similar to clusters A and B, but their social communication profile is more mapping onto cluster C. So maybe that's clinically meaningful. We don't have the outcome data yet to be able to say, to look at that yet. But that's kind of one application of using this kind of analysis and this kind of looking at these different profiles. It could also be used for things like treatment planning, where since we have this kind of developmental progression, so we have someone in cluster F, where we know that the main difference between cluster F and cluster E is whether or not they're using joint attention behaviors. Maybe that's what we focus on in treatment, because we know that's the next skill that's about to emerge. And then kind of like what I talked about before, these profiles really allow us to do some more sensitive phenotyping, where we can start to see some variability within syndromes, and get at some, individual differences and strengths in these skills. So just kind of summarize and think about how do we use all of this moving forward, and how is this applicable? And also, this is kind of where like my research, I'm hoping to take it next. So I think one thing that's kind of a theme from this is that we can use statistical approaches to contextualize our existing measures. So without going into these more kind of like detailed coding schemes or developing new measures, there are some approaches that we can take to, do better with the measures that we have. I think there are clear benefits of the remote naturalistic assessment route, especially for these populations that are going to be maybe a little bit more affected by new settings, new people. And what was really promising is that we can get really good data from those kinds of assessments too. I think when thinking about like the type of, the context of the behavior that we're collecting, comprehensive samples like the Lena, where you're getting a full day of recording, I think they really optimize the generalizability. Like you're getting a much broader sample. So hopefully, you're reducing the effect of noise within that sample. On the flip side, brief samples like the ones that we have used, like the parent-child interaction or the 10-minute interaction that we coded where we saw differences in vocalization features, those are nice to kind of quickly, if we're thinking about clinical applications, those are the ones that are probably going to be a little more, easy to integrate into an assessment an assessment process or give quick feedback to a family in terms of what their child is doing on these different skills. And so I think especially this kind of like comprehensive sample versus brief sample is one I grapple with a lot, because I think you get really good data from these long samples, but like you're not going to be able to code a full day of, a full day of utterances and give something meaningful back to a family. So I think there's this trade-off that I'm always grappling with in terms of applying this kind of clinically. And I think how I've kind of conceptualized this is that different strategies are maybe useful for different parts of the process. So if we're talking about like monitoring, likely eventual outcomes, maybe remote assessment is a good way to kind of keep an eye on things or notice, if we notice certain profiles start to emerge, that's when you then kind of, refer for a diagnosis or something like that. Whereas diagnoses, I think we do rely on really like standardized measures, and perhaps for good reason for that too. But I see a lot of benefit in terms of like using some of these methods for intervention planning and being able to, again, kind of tailor what we're working on or the supports that we're giving to the more nuanced skills in areas where we're likely to see growth for these kids with neurogenetic syndromes. So I think kind of mapping on these different approaches to like where in the process are they going to be most beneficial is definitely an important consideration. So with that, I would just like to, thank my advisors. I've had funding from NIDCD and also from the, not my project, but my advisor's project was from NIMH. We've had lots of support for recruitment from various syndrome foundations, and then of course, lots of families that have participated in our research and devoted many, many hours of their time to help us answer these questions. So we're always very appreciative to them. And I'm happy to answer any questions with the 5 minutes we have left.
Lisa, first, I'll just say thanks so much for running through all that. It was fantastic, a lot of data, and impressive. I know those are particularly challenging studies and really important questions because a lot of us who've worked with either autistic individuals or individuals with different genetic conditions that are associated with autism really struggle with this challenge of the floor effects, and there's real limitations in variability we get out of our data. I see Maggie Campbell's hand up to ask the first question, but I want to invite others to either, as Cassie said, you can put questions in the chat or raise your virtual hand or just unmute as well. But we'll let Maggie go first, and she was doing the virtual thing.
Thanks, Lisa. That was a great talk, and I'm really looking forward to reading your recently published paper. I think we have a lot of overlapping interest in early communication and early language development. I was curious if you have any if you had any results about the reliability between the Lena coding and the more so hand coding from the trained undergrads.
We have had that discussion many times. I don't think we've ever kind of like explicitly looked at that because our coding system's not set up to kind of do justice to looking at how reliable Lena is. We have kind of an added element of since we're looking at vocalization pitch, we also kind of kick out any vocalizations where there's like other significant overlap with other voices. And so, but we don't necessarily like code it as overlap. We just code it as like not usable. So we have like some measure of, is what Lena's coding as child vocalization actually child vocalization, but it's a little bit like deflated, doesn't map on quite exactly just because of the way we code things. I will say, looking at like the rate of non-codable utterances across the different groups doesn't seem to differ too much. So kind of just from the coding that we've done, we feel pretty confident in saying like, at least in Angelman syndrome and Down syndrome and Fragile X syndrome, Lena is not like, doing significantly more kind of like identifying of child vocalizations for the segments that we pull out. So it's not a perfect answer, really but helpful. Yeah.
No, it's really helpful. I've gotten feedback on a grant application that had Lena as one of the collection methods, and that was some feedback that like it was not reliable in identifying parent versus child vocalizations.
Yes, so that's a question that we can't really answer with our data, and I feel unsurprised that you got that feedback too, because I think in some of the more non-syndrome Lena circles that I run in, that tends to be a pretty big question too of differentiating between like the child and the adult.
Thanks so much.
Thanks, Lisa. I see Jay's hand up.
Yeah, I would echo all that. This is really, really cool stuff you did, Lisa. And I was wondering, kind of related to Lena, number one, if you, I like the little package that you're sending to the parents. And I noticed that it included like a Lena and the little vest and everything. If you wanted to use something, I don't know if you're using the Lena because it supposedly has really good high quality recordings, or obviously it's going to give you some output as well. But most smartphones have equally high recording capabilities, and just a heads up, we published a study on that, just comparing smartphones to Lena. And their hardware it's fine, but it's not much better than smartphones, and most parents have that just to make it a little bit more cost effective. And I was wondering too, have you guys thought about like using machine learning or anything to measure like the pitch differences, the canonical versus non-canonical babbling?
Yes, I think that is probably the next step in my training. So I'm at the point where I'm thinking about what my, what is the next grant what am I going to focus on? And I think it's going to come back to some of these methodological things, which is, machine learning as a method is kind of how I think about it. But yes, I think learning, and kind of to speak to also the first thing you talked about with, I know there's other methods of getting at like the segmentation that Lena does too. And it just requires a little more, programming than I have the capacity the training for now. But I think, yes, I think there's lots of exciting new, technological advances that are gonna just continue to make this kind of analysis more streamlined, and hopefully more effective too.
Yeah, because what you're doing, trying to find ways to make that data collection easier, and that, what is it, Zoomverse?
Zooniverse, yes.
Zooniverse. Yeah, I'd never heard of that. That's kind of cool. But yeah, finding ways to make it easier to code. That's kind of what we're starting to get into with some of
Yeah.
our stuff. So nice
Exciting.
stuff.
Thank you.
I kind of want to know who those people who are coding other people's data in their
Mhm.
spare time are. I don't judge. I want to know who they are.
I
So,
think there is a study. I think I was recruited because I tested out some Zooniverse coding, and then I think someone was doing a study of who the Zooniverse coders were in terms of like
yeah,
what level of education did they have, like what is their
right.
background in, how many kids do they have, like, right, what's their exposure to early child development. So I haven't heard, I don't know where in the process that publication is, but I think it's an
Interesting.
interesting question too. Yeah.
Yeah, I want to know what their motivations are. So.
Yeah.
I will say I want to be respectful of your time. We're a little bit over the hour, but before we sign off, I did also want to say this is really exciting. Also, from you didn't talk about as much about it, but as you're thinking about your future directions, I will just say for multiple fields, I think there's real importance here, and it's been real value in Nancy's work in the development of the communication complexity scale as well. But it makes me think about some of the work that's going on in Fragile X, where they're starting to be able to. There's certain groups in particular up in Cincinnati, and Lauren Schmidt is gaining resolution for detecting lower levels of protein, so that you're starting to zoom in on that and get variants. And so I hear you in terms of the clinical implications of this work, and it seems really exciting, especially if you start tracking these kids over time. But I would also suggest that there's real value in the work that you're doing from a mechanistic perspective that could really advance field of Fragile X, but also other monogenic conditions. So it's exciting stuff. So
Yeah, thank you. Yeah, I agree. I feel like there's a lot of promise in the direction that this work can go.
And you're in a good place to do it now. I just saw Jane yesterday, so you're in a fantastic environment for that. So
yes, very
good
supportive.
stuff. Well, thank you so much for doing this, Lisa. It was wonderful to hear about this work. We look forward to any and all future updates as this work accelerates. And so we appreciate your time and look forward to being in touch.
Of course, yes. Thank you so much for having me.